Hello everyone and welcome to the cumulative test review video, and I'm going to be going through every question step by step, so feel free to flip through to the questions that you need, and definitely please do the entire review packet. It's very important in order to feel prepared for this test. This review packet will be due the day of the test, which is Friday the 29th. So let's get started. Numbers 1 and 2 ask, let's completely simplify the following expressions. Now notice, this is not an equation. We don't have any equal signs, so all we're doing is combining like terms and distributing and getting a final answer from there. So for number 1, I would look and notice that my x squareds can be combined as like terms. My negative 3x doesn't have anything else it can combine with. My 7 and negative 15 can be combined together. So my final answer, 2x squared minus 5x squared is a negative 3x squared. Negative 3x doesn't have a buddy, so it stays the same. But 7 and negative 15 combined together would be a negative 8. So because none of these are like terms anymore, I am done here. And this is not an equation. It does not have an equal sign, so I cannot actually solve for x. Number 2, it looks like the first thing I could do is distribute on both of these situations. And if I do so, I can eventually combine like terms. So we would get 2 times 2, or 4, minus 2x, negative 3 times positive 3, negative 9. Negative 3 times negative x is a positive 3x. Again, if we think about like terms, 4 and negative 9 can be combined together. Negative 2x and positive 3x can be combined together. 3x minus 2x is a 1x. 4 combined with a negative 9 is minus 5. So you could either write your answer like this or as just x minus 5. Please don't solve this any further because this does not have an equal sign. The next review topic from Chapter 1 is performing fraction operations, adding, subtracting, multiplying, and dividing. And please remember that only when you're adding and subtracting fractions is when you need the common denominator. Otherwise, you can use the reciprocal when you're multiplying and dividing, if applicable. For the first problem, number 3, let me just rewrite it with a little bit more room. We have 2/3 plus 4/7, and what we need is a common denominator. So the common denominator between 3 and 7 is 21, and the way you can think about it is this denominator currently has a 3, and we need the 7. So we'd multiply top and bottom by 7. This fraction has the 7, it needs the 3, so we'd multiply top and bottom by 3. Then we would multiply to get what our common denominator. So we get 14 21st plus 12 21st. The denominator never changes, so my denominator is going to have 21. 14 plus 12 is 26. I look at my fraction. There is no number that divides evenly into both 26 and 21, so I'm done here. For number 4, you absolutely need a common denominator again because we're subtracting, and you could multiply this fraction by 5/5 and multiply this one by 10/10 like we did this problem. But some of you might notice that if you're thinking what's the first number that 5 and 10 go into, you can do something much smaller than 50. So if anyone likes this, you could just take the first fraction and multiply that by 2/2, because then this gets you the denominator of 10, which is already there. So you would get 6/10 minus 11/10, which would end up being negative 5/10, which now if I divided both by 5, I would get an answer of negative 1/2. If you decided to do number 4 like number 3, you would still get the same answer. Number 5 this time is multiplying two fractions, so we don't need a common denominator. In fact, what you could do is multiply straight across. And if I do that, 2 times 10 would give me 20. 5 times 15 would give me 75. You could look at both of these numbers and notice, just like the last one, that you could divide each by 5 at least. And so if you did that, 20 divided by 5 is 4. 75 divided by 5 is 15. You can't take anything else out, so 4/15 is your answer. Now again, some of you might like the fact that if you cross cancel, 5 goes into 10 twice, so you could reduce it like this and then multiply across. Get 2 times 2 is 4, 1 times 15 is 15, so you get 4/15 this way as well. Number 6 is asking you to take a fraction divided by a fraction, which is the same as the first fraction multiplied by the reciprocal. So remember, whenever you're dividing fractions, that's when the reciprocal is going to come and help you. And so first fraction multiplied by the reciprocal of the second fraction. Now that it's multiplication again, you could multiply straight across. 5 times 3 is 15. 8 times 20 is 160. And funny enough, for the third time on these problems, I know that both of these are divisible by 5 because it ends in 5 or 0. So 15 divided by 5 is 3. 160 divided by 5 is 32. So that, I think, is going to be my final answer. The next set of problems is using the order of operations. So this is another kind of Chapter 1 review thing, which could be on this test Friday. So for number 7, remember, for the order of operations, we want to follow this idea that parentheses come first, exponents come second, multiplication and division are on the same plane, and addition and subtraction are on the same plane. And you always want to go left to right if possible. Number 7, I noticed parentheses first, so I'm going to reduce in there first. 5 minus 7 is negative 2 squared, and I'm going to write everything else down so I don't lose anything. Next thing is we have exponents. Remember, negative 2 squared is the same thing as negative 2 times itself. So we have two negatives. So this really becomes a positive 4 minus 6 divided by 3 times 2. Subtraction comes later, so I'm between division and multiplication. I always have to go left to right. So I would have to go 6 divided by 3 first, which would give me 2. Recopy. Between subtraction and multiplication, I would have to do multiplication next and get 4 here. So my final answer is 4 minus 4, or just the number 0. Number 8, remember that a fraction bar is really a grouping symbol. So you would do the numerator separate from the denominator to start. And on the top, if I'm looking at division, multiplication, and addition, I again want to go left to right. So I'm going to do this division first. 8 divided by 4 is 2. And again, I'm just going to recopy what I have there on the top. At the same time, because we have two separate problems in a way, I'm going to reduce what's in the parentheses to 2. In the numerator, multiplication comes before addition, so I'd really get 4 plus 1 on the top, 5 times 2, or 10 on the bottom. 4 plus 1 is 5, 5/10. If this can be reduced, you can again divide by 5. Common theme of this review packet. This answer would be 1/2. One of the last pre-algebra topics that we covered was converting from fractions and decimals to percents in any order. And so I thought this chart would be a good way to review that material. And so let's start with the first one, given a percent of 35%. Remember that percent really means out of 100. And so the double zero represents how many times you're moving the decimal. And because there's 2 zeros, we move it 2 places. So right now, remember that our decimal is here, and if we're going from a percent to a decimal, the number is getting smaller, so you have to move the decimal twice to the left. So the decimal is actually 0.35. And if I want to convert this into a fraction, there are 2 decimal places behind the, or 2 places behind the decimal. So that would really be 35 out of 100, the 2 zeros representing the 2 decimal places. 35 and 100 can again be divided by 5, very common it seems. 35 over 5 is 7, 100 divided by 5 is 20. So this fraction is 7/20. If I start with a fraction, remember that a fraction is really division. So in my calculator, if you take, or in yours also, if you take 19 divided by 40, you should get 0.475 in your calculator, which then can be converted into a percent because, again, out of 100, except for this time, I am getting larger. So my decimal would move 2 to the right. So I'd have 47.5%. And please keep it as 0.5. 48% is a little bit different. If you're given a decimal originally, you can go either direction. If you want to go to the percent first, remember that you are moving the decimal twice to the right. So this would be 14%. And if you'd like to go to the fraction, there again are 2 decimal places after the decimal point. That would be 14 out of 100 originally. Both are divisible by 2. 14 divided by 2 is 7. 100 divided by 2 is 50. You might notice that this review packet is written in complete opposite order, that I started with the pre-algebra topics, and now I'm going to, so I'm starting with the stuff we did at the beginning of the year and moving towards the newer, because I think it'll help with the memory. So let's get to one-step equations beyond to review some of that. Number 10, my goal is to get the x alone, and so I need to move the 4/5. So the first thing I'd have to do is subtract the 4/5 because it's being added. So you have x equaling -7/8 minus 4/5. And this reminds me of the fraction work we did a couple slides ago. Because I'm subtracting, I need a common denominator. So this fraction has the 5, so it needs 8/8. This fraction has the 8, so it needs to be multiplied by 5/5. If I multiply now, 5 times -7 is -35/40 minus 4 times 8, 32/40. Denominator is still 40, but -35 minus 32 would get me a -67/40. What a lovely answer, huh? Number 11, my goal is to get x alone. And so the number that's on the same side but not attached to x is the 3. So I'd have to do the inverse and add 3 first. So I'd have x divided by 2 equals -8. Then if I want to get 2 to the other side, it's being divided. So I'd have to multiply both sides by 2. So my final answer would be x equals -16. Number 12 looks like I'm going to do the distributive property first. So I get -24 equals -3 times 2, -6x, negative times negative, +12. If my goal is to get x alone, let's move this non-attached 12 to the other side. So I'd have -6x equals, if I combine -24 and -12, that would be a -36. So now if I divide both sides by -6 to get the x alone, my final answer would be a +6. Number 13, looks like on this side, I have to do the distributive property of 1/4. And remember that multiplying by a 1/4 is the same thing as dividing by 4. And on this side, remember that there's really a -1 in front of this parenthesis, so that is what you actually are distributing. So if I go through that, 1/4 times 12, or 12 divided by 4, is 3x. 28 divided by 4 is really 7, equals 3. If I distribute the negative, we'd have -5x. Negative times negative is a +12. If I combine like terms on this side, we would get -5x, 3 and 12, plus 15 equals 3x plus 7. Now that I have variables on both sides, I'm going to move my variables together first, and I'm going to add 5x and get 8x plus 7 equals 15. Now I want to get rid of the 7, so I'd have 8x equaling 8. Divide by that 8, your final answer would be 1. So at this point, I'm going to move to video number 2. So please join me at video number 2 if this video is helping so far, and feel free to skip to the questions that will help you. See you in the next video.